Okay, it seems like we've hit 200 attendees and there's still a few filing in, but we'll start. Hi, hello everyone. Good morning. Welcome to the public workshop on the heavy duty engine and vehicle omnibus regulation amendments. I'm Christian Bartolome. I'll be helping moderate this workshop. Before we get into it, I'd like to mention a few logistics for today's workshop meeting and some Zoom webinar details. So a lot of us are joining in by phone or by our device, but if you want to call in by phone, that's also available. The telephone number and access code is on the screen. After each presentation today, we're going to have a time for questions, and the way to interact is to use the raise hand feature in Zoom if you want to ask a question like vocally. You may also type in a question using the Q&A box feature. If you're on the telephone and you'd like to raise your hand, you can do that with #2. And then when I'm going through the raised hands, I'll call out to you and let you know that you can unmute yourself. And if you're on the phone, you can do that with *6. We ask that you please state your name and affiliation before asking a question or making a comment. I also wanted to note that today's webinar is being recorded and should be posted on CARB's YouTube website within the week. Okay, to the agenda. So here's a brief agenda of what we're going to be going over today. We're going to have opening remarks by Kim Rogalski and Paul Adnani, followed by the heavy duty engine vehicle omnibus regulation and alignment by Daniel Hawalti. And then we're going to have third is the in-use corrective action requirement update by Adil Mahmoud. And then we have two presentations from OBD. The first one is the real assessment logging, oxides and nitrogen NOx tracking requirements update by Paul Hendrick, and OBD aging presentation by Yong Yu. Our last presentation will be the in-use testing amendments by Tom Montes, and then we will have closing remarks by Paul Adnani. Okay, so for the opening remarks, I'll pass it to you, Kim and Paul.
Good morning. Thank you, Christian. Yeah, my name is Kim Rogalski. I'm Chief of the Mobile Source Reg Development Branch at CARB. And thank you so much to everyone for taking time to attend this workshop. What we'll be talking about today are amendments to our omnibus regulation that would take effect with model year 2027. Many of you may have participated in some amendments we did to the reg last year that are still making their way through the very last stages of the California rulemaking process. And those changes that were heard at an executive officer hearing last year will become effective with model year 2024. But today we're looking further ahead and talking about model year 27 and putting in place some of the commitments we made in the Clean Truck Partnership. So with that, let me kick it to Paul.
Thank you, Kim. Good morning and good afternoon, everyone. Thank you for joining us on this very first day of spring. My name is Paul Adnani, and I manage the on-road heavy-duty diesel section. We have a lot of material to cover today, so I'll keep this as a very short introduction. There's a couple of issues I want to point out, and I'd like to sort of keep those in mind. One is the proposals that we will be presenting today apply to 27 and subsequent model years. We are not going to be talking about 24 to 26 model year products. And then the second point, which is Kim sort of mentioned that CARB did sign the Clean Truck Partnership last year. Some of the proposals that we will be talking about today have to do with our commitments under that agreement. But we also have other proposals that really have nothing to do with the agreement. So it's for example, the OBD program proposals, those were not part of the agreement. And that is all that I had. So I don't know whether Christian or Daniel is going to go next.
All right. Daniel will start us off with our first presentation on the heavy-duty engine vehicle omnibus regulation amendments.
You're on mute, Daniel.
Daniel, you're still on mute. We can't hear you right now. Let me see here.
Hi, Christian. This is Tom. Can you hear me?
Hi, Tom. I can hear you.
Okay, just checking.
Okay. Okay, it looks like
I
Daniel.
am back. I am back. Sorry.
Okay.
Apologize.
Thanks, Daniel.
Okay. So, yeah, good morning. Thanks, Christian, and good morning. My name is Daniel Hawalti. And from the outline that you can see, I will be presenting the background of the rulemaking, and then the first bullet from the second bullet, that is, I'm going to be talking about the proposed amendments to the emission standards and test procedures. Next slide. Okay, just a background. As we know, heavy-duty vehicles are the largest contributors to NOx emissions in California, and therefore significant NOx reductions are needed from this class of vehicles to achieve California's air quality goals. CARB has developed a multi-pronged approach of regulatory and voluntary incentive programs to reduce NOx emissions from heavy-duty vehicles. And the Omnibus regulation, which was adopted by the board in 2021, is one of those programs designed to provide significant NOx emission reductions, and it is a vital program for achieving our SIP commitments for 2031 and 2037. Next slide. The table shows a comparison of the major elements included in the Omnibus regulation and EPA's NOx rule. First, there is a difference in the applicability of the two regulations. The Omnibus applies to 2024 and later model year engines that are used in vehicles greater than 10,000 pounds, while EPA's NOx rule applies to 2027 and later model year heavy-duty engines used in vehicles greater than 8,500 pounds. And both regulations apply to spark-ignited and compression ignition heavy-duty engines. Same thing, both regulations modify the same regulatory elements. That is, they include similar certification test cycles, and the corresponding standards are similar with slight differences. And both programs modify the averaging, banking, and trading program, the warranty period, and the useful life periods. Both regulations also modify the in-use testing program and use the moving average window methodology for analyzing emissions. Next slide. In July of last year, CARB, the Engine Manufacturers Association, and its members, and Ford Motor Company signed the Clean Trucks Partnership Agreement. In this partnership agreement, CARB committed to provide more flexibility for the 2024 through 2026 model year engines by increasing the allowed number of legacy engines. CARB also agreed to harmonize with the federal rule for 2027 and later model year engines. The agreement also specifies the areas where CARB will maintain its own programs. Manufacturers, in turn, agreed to fully comply with California's heavy-duty truck regulations, including the Omnibus and the Advanced Clean Trucks regulations. Next slide. In this workshop, in general, staff is proposing to largely align with the US EPA-NOx rule for 2027 and later model years. However, CARB will maintain its own certification program, its own onboard diagnostic program, its own emission warranty information reporting program, and its own heavy-duty in-use testing program, except for aligning with EPA's two-bin moving average window methodology, as well as the off-cycle standards as agreed in the partnership. CARB will also maintain its clean idle requirements as a mandatory requirement, as opposed to EPA's voluntary requirement. Next slide. Staff is proposing to align the Omnibus certification standards for 2027 and later model year engines with the federal certification standards for both compression ignition and spark ignition engines. For compression ignition engines, the standards are based on existing certification test cycles, such as the FTP and the SET, and a new low load cycle intended to address low load operations. For spark ignition engines, the standards are based on the existing FTP duty cycle and a new SET duty cycle intended to address high load operations. In addition to NOx, EPA also established reduced standards for particulate matter, hydrocarbons, and carbon monoxide. Staff is also proposing to align with these standards. Next slide. Next is a durability demonstration program. Manufacturers are required to demonstrate that the engine and after-treatment system will meet applicable standards throughout their regulatory useful life. And staff is proposing to align with the durability demonstration provisions in the EPA rule. This would include the method for determining deterioration factors for new engines, which would include dynamometer aging of the engine and after-treatment system for a fraction of the useful life, and accelerated bench aging of the after-treatment system for the remainder of the useful life. Additionally, the program would require manufacturers to verify the DF, or the deterioration factor, in use using engine dyno testing or portable emissions measurement system, or PEMS testing. Currently, Omnibus requires manufacturers to submit in-use emissions reports for DF verification. For 2027 and later model year engines, manufacturers would no longer be required to submit these in-use emissions reports. Next slide. The averaging banking and trading program provides manufacturers with a flexibility in their product planning, while also encouraging the early introduction of emission control technologies. Starting with the 2027 model year, staff is proposing to merge the California ABT program with the federal ABT program, and also allow the use of credits accrued under the federal ABT program to certify 50 state engine families in California. The proposed NOx family emission limit caps are 65 milligrams for model years 2027 through 2030, and 50 milligrams for model years 2031 and later. Additionally, credit accrual from zero emission powertrains would not be allowed for 2027 and later model year engines. Also, there would not be an ABT program for hydrocarbon, CO, or PM for 2027 plus model years. It means that for these pollutants, manufacturers have to certify to the standards. Next slide. Moving on to the useful life. The useful life period is the period for which the engine must remain emissions compliant. And staff is proposing to align with the useful life values for mileage, years, and hours in the federal NOx rule for 2027 and later model year engines. Just as a note, for the heavy engines, the useful life, which is 650,000 miles shown in the table, is a period that the engine should remain compliant with the standards when the vehicle is operating in the real world. However, manufacturers are required to demonstrate durability as certification for a longer useful life of 750,000 miles. And this is intended to ensure that the final standards will be met throughout the longer useful life of 650,000 miles when these engines are operating in the real world. Next slide. Staff is proposing to align with the warranty periods for mileage, years, and hours in the EPA-NOx rule for 2027 and later model year engines. The warranty periods are as shown in the table. Next slide. Moving on to the in-use standards, staff is proposing to align with EPA's two-bin moving average window methodology and off-cycle standards for 2027 and later model year engines. Emissions are collected using PAMS when the vehicle is operated in use, and then analyzed using 300-second moving average windows each second. Window emissions are then placed into a bin depending on the type of operation. And bin 1 represents window emissions at idle or at very low load operations, and bin 2 represents window emissions for low, medium, and high load operations. Staff is also proposing to align with the PAMS accuracy margin, which is equal to 0.4 gram per hour for bin 1 and 5 milligram per horsepower hour for bin 2. Next slide. Continuing with the in-use standards, staff is proposing to align with EPA's 15 milligram per horsepower hour interim compliance allowance applicable for bin 2 off-cycle standards for medium-heavy and heavy duty in-use engines. However, there are differences between CARB and EPA's applicability of the margin. For EPA, the interim compliance margin is permanent. That is, it is applicable for 2027 and later model year engines. For CARB, the provision would sunset in 2035. This proposal, CARB's proposal is based on the partnership agreement signed between CARB and the industry. Next slide. Another margin or adjustment is a temperature adjustment. It's an additional margin added to the applicable off-cycle NOx standards based on the ambient temperatures. And the chart shows the idle bin off-cycle standards for CARB and EPA. As you can see, the EPA showed in red dashed line the temperature adjustment applies for ambient temperatures between 5 degrees C and 25 degrees C. And it applies for 2027 and subsequent model year engines. It's permanent. For CARB, however, the temperature adjustment shown in blue would apply for temperatures between 5 degrees C and 20 degrees C until model year 2030. For 2031 and later model years, the temperature adjustment would apply only for ambient temperatures between 0 and 5 degrees C. And that is shown by the green line. Next slide. Continuing with the temperature adjustment, the two charts shown here are the left is the off-cycle bin 2 standards for medium heavy and heavy duty engines, and on the right is light heavy duty diesel engine bin 2 off-cycle standards. So for EPA, as shown in red line, the temperature adjustment applies for ambient temperatures between 0 and 25 degrees C, and it is permanent starting with 2027 model year. For CARB, it would apply for ambient temperatures between 0 and 20 degrees C until model year 2030. For 2031 and later model years, it would apply for ambient temperatures between 0 and 5 degrees C. Next slide. Okay, moving on to the SCR inducement requirements, and staff is proposing to align with EPA's SCR inducement requirements for 2027 and later model year engines. SCR inducement requirements are developed to ensure SCR control systems are functional, effective, and tamper-resistant. The requirements also encourage owners to maintain adequate supply of high-quality diesel exhaust fluid to the SCR system and discourages tampering of the SCR system. Next slide. Currently, California transit agencies can purchase transit buses equipped with federally certified engines instead of Omnibus compliant engines. Since CARB is proposing to align with the federal requirements starting with the 2027 model year, there would be no need for this exemption. As a result, staff is proposing to sunset this exemption starting with the 2027 model year engines. This concludes my presentation. Thank you. Back to you, Christian.
Thank you, Daniel. Just a reminder, if we're going to have time for questions here. Around 10 minutes. Again, you can ask questions using the Q&A box feature or raise your hand. Okay, we have one question. Maybe actually the first hand raised was from Alexander Titkov. So I'm going to allow you to talk, Alexander, and if you can unmute yourself, you can ask your question. Alexander, you can unmute yourself. Okay. I see you unmuted yourself, but we can't hear you, Alex. Okay. Maybe we can get back to you. Let's go to our first written question. What is the equivalent full useful life hours to 750,000 miles? To how many hours will combined service accumulation and accelerated aging be required for various HD categories? I think Paul wanted to answer.
Yeah, I can go ahead and address that. So the aging in the laboratory involves using accelerated after treatment aging, and the number of hours would be a sort of a function of how fast that accelerated aging could be simulated. The latest data that we have from Southwest Research sort of estimates a factor of 10 in terms of acceleration. So it would really depend on what kind of a process that you use.
Thank you. Our next question comes from Luke Spinolo. Is CARB considering alignment with EPA's applicability and certification options for Class 2B and 3 vehicles? In particular, allowing engine dyno certification of 8,501 to 10,000 pound gross vehicle weight rating incomplete vehicles, a certain 10,000 to 14,000 pound gross vehicle weight rating complete diesel vehicles, or any vehicles over 22,000 GCWR as proposed by EPA's multi-pollutant rule, NPRM?
So there is, within the CARB program, anything that is certified with GVWR under 10,000 pounds would have to go through chassis certification. Anything that's between 10 to 14,000 pounds, the manufacturers have the option of doing either engine certification or chassis certification. And anything above 14,000 pounds would be just engine certification. So between 85 to 10,000 pounds, the only option for CARB would be chassis certification. And that's been the case for many years now.
Thank you, Paul. Our next question comes from Jackie Yeager. What is CARB's proposal for spark ignition off-cycle standards or protocols?
Yeah, we welcome any comments in that regard. Our current thinking is to sort of use the FTP cycle standards for spark ignition engines and not have off-cycle standards for spark ignition engines. But if any of the that has not been fully decided yet. We're taking comments from stakeholders in that regard.
Thanks, Paul. We had a raised hand from Mike Tunnel. So, Mike, I'll ask you to unmute. You can ask your question.
Can you hear me?
Yeah, we can hear you, Mike.
Okay, wonderful. Hey, thanks. Mike Tunnel, American Trucking Associations. Appreciate you guys holding this. Just a question. So on the current requirements, there are requirements for California certified vehicles to be sold and operated under the ACF reg in California. And I'm wondering on the alignment, so the standards will be aligned, and this gets at the question of deemed to comply. It looks like there'll be California certification and federal certification, and I believe the rules as written today require California certified engines to be used in California. Will we be, since the standards are all aligned, will every engine sold in 27, regardless of where it's sold, be able to operate in California, or will we still be in this situation where there's, like 3 different types of engines and only some of those can operate in California?
So I think that the first thing we want to mention is that within the Clean Truck Partnership, it made it clear that it won't be, we will have our own certification and OBD and in-use programs. So there won't be any pathway for a deemed to comply option. Our thinking, the question that you're asking, some of it has to do with how manufacturers will sort of look at this. The standards, certification standards are the same, but the in-use standards are, as Daniel showed you, are somewhat different. So whether the OEMs would have a single 50-state certified product that would meet both California's more stringent requirements for in-use emissions, that is, up to the OEMs. Our thinking is that is certainly possible, but we can't speak for the manufacturers. Did that answer your question, Mike?
Yeah, that's helpful. I mean, just I think the message is, if you can, there's definitely confusion under the current system, and as you move forward on this alignment, as much as we can truly align for purchasers, that would be helpful.
That's the intent. That's our intent to do that. But again, it will be up to each individual OEM to sort of decide whether they will do 50-state certification.
Okay, thank you.
Is that coming through, Mike? Because the standards will be pretty much identical, but there's some like provisions of the in-use testing that will remain different. So like a manufacturer could say, you know what, I'm just going to meet California's requirements for all my trucks, and then everything would be seamless. But if someone chose not to do that, then they'd still have the same sort of more complicated situation where there's 2 different. So like there is today.
Right. Yeah. No, that right. There is that potential for still having 2 different certifications, it sounds like, but yeah, hopefully it can get aligned.
Yeah, there will be certification by both CARB and EPA, right? Because the scenario I think that you have in mind is 50-state certification, where an OEM would go to EPA, get their certificate, and they would come to CARB with the same product, saying that we will meet California's requirements, and they will get the ARB executive order, and it will be a 50-state certified van.
Okay, great. Appreciate it.
Sure.
Thank you, Mike. Thank you, Paul and Kim. All right, our next question is, with the exemption language described here on slide 19, does it mean that since CARB is harmonized with EPA, that an EPA engine can be used in California on a transit hybrid bus without the need for a transit property to apply for an exemption?
So again, we're thinking that an OEM would come with a 50-state certified family that's been certified by both EPA and CARB. And because they do that, there will no longer be this exemption, to use only a federally certified product. The reason we had this exemption before, it was because the standards and the warranty requirements were different between EPA and CARB. That's why we had this exemption for transit. But given that, we're trying to harmonize to the extent that possible with EPA, we don't think there's any need for this exemption process anymore. Starting 27 model year, I should say.
Thank you, Paul. Our next question is, how does useful life and warranty requirements apply to hybrid components?
The warranty requirements would be the same as what would be offered by EPA. So we intend to harmonize with those requirements.
Okay. Our next question is from Tim French. Will CARB be adopting EPA provisions regarding minimum moving average window counts, i.e. 10,000 windows for bin 2 and 2,400 windows for bin 1? I think I can answer.
Yeah, the
that
short
one.
answer is yes.
Yeah. Yes. Okay. Our next question is, the standard in grams per hour or milligrams per horsepower hour on slides 16 and 17. The mass is not very sensitive to temperature. How will temperature adjustment impact these results in standard?
Can we go back to slide 16 and 17
Sure,
so
yeah.
make sure we know what we're looking at? Well, I mean, the question is, they're not very sensitive to temperature. Yes, until 20 degrees C, but after that, as you see, the standards do go up. And these are the ambient temperatures, by the way. So depending on what's the average ambient temperature is for the test day, you're going to have different set of standards. But I don't know. I'm just looking at the green. Go back to the
Oh, I'm
previous.
sorry.
Yeah. I'm just looking at the green line. It looks like between 5 to 0 degrees C, the standard goes up by almost 20%. So whether that's very temperature, whether you want to call that very temperature sensitive or not, to me it is.
Thank you, Paul. Our next question comes from Tom Croissant. Will NZEVs broadly fit into the same emissions requirements as shown in the table and enable potential hydrogen to ICE hybrid and or natural gas RNG engines to still participate in ABT generated credits?
So first thing I want to say is that NZEV is not a term that is defined in Omnibus. I presume you're referring to hybrids. I can go through each one at a time. Hydrogen internal combustion engines, yes, whether they would fall under the spark ignition or compression ignition category, yes, they would be subject to the same emission standards that were shown to you. Same thing with natural gas and RNG. Hybrids, I guess they have various pathways. You could, either certify the engine or certify the hybrid powertrain. So. But yeah, under those, yeah, they would be subject to the same standards that were shown to you.
Thanks, Paul. Our next question is related to slide 15. Slide 15. Is slide 15 related to off-cycle slide 14?
So yes and no. I mean, they apply to in-use standards. The interim in-use compliance applies to off-cycle standards, but it also applies if you take an in-use engine and take it off the truck, basically, take it to the lab and put it on a dyno. That is still considered an in-use engine. So the compliance allowance would apply to lab testing in that scenario as well.
Thank you, Paul. Okay, I'm doing a time check here, and we have a few more questions, but we need to save them for our Q&A session at the end of the workshop.
Yeah.
So I'm going to stop sharing here, and then I'm going to begin sharing our next proposal. Our next presentation by Dil Mohammed.
Yeah, thanks, Christian. Good morning, everyone. My name is Adil Mahmood. I work in the field operations and warranty section. And in this presentation, I will be going over updates to the in-use corrective action requirements. Next slide. The California Air Resources Board requires manufacturers to follow specific requirements when conducting recalls. Some corrective action is required when emission-related components equipped on engines exceed corrective action thresholds that are specified in the California Code of Regulations, Section 2143. These thresholds have recently been adjusted to account for longer warranty periods. CARB objectively evaluates all information submitted by manufacturers pursuant to California Code of Regulations, Section 2146 and 2148, in assessing whether corrective action is required. Due to the advent of over-the-air technology and the proliferation of internet availability, certain requirements are being updated. In this presentation, I will go over updates to the requirements that will help streamline the recall process while maintaining its effectiveness. Next slide. The first update that we are making is to the recall repair label requirement, which is currently required by California Code of Regulations, sections 2116, 2128, and 2169.3. These labels are used to indicate that a recall repair has been made to an engine. Currently, manufacturers are required to affix a recall repair label to vehicles after a recall repair has been completed. If a vehicle is repaired over the air, manufacturers must mail a recall repair label along with instructions on how to affix the repair label to the vehicle owner. The proposed update to this requirement will exempt manufacturers from the recall repair label requirement if certain conditions are met. First, the recall must only involve a software change and not make any changes to hardware. Second, the manufacturer must keep a record of VINs for all vehicles that were inspected or repaired. Lastly, upon request from the executive officer, the manufacturer must provide information about running changes, field fixes, service campaigns, and recalls for any given VIN from all vehicles affected by the nonconformity. Engine serial numbers cannot be used in lieu of VINs. This is not possible because the DMV system requires VINs to be used for recall registration holds. Next slide. Another update will be to the proof of correction certificate requirement. These certificates are provided to vehicle owners after a recall repair has been completed and can be used by vehicle owners to have a recall registration hold removed by the DMV. Currently, for over-the-air recalls, during the first 6 months of a recall, manufacturers must mail a hard copy proof of correction certificate or provide an electronic copy to vehicle owners that have a recall repair performed over the air. The proposed update will make it so that during the first 6 months of a recall, manufacturers will not have to provide a proof of correction certificate to vehicle owners that have the recall repair performed over the air. A hard copy proof of correction certificate must still be provided if the recall repair is performed after the first 6 months of the recall, because the DMV will not accept an electronic proof of correction certificate to remove a registration hold. Next slide, please. Lastly, we will be updating the requirement for new owner information collection. As part of the current requirement, manufacturers must provide a card to be used by a vehicle owner in the event that the vehicle to be recalled has been sold or transferred. Such card should be addressed to the manufacturer, have paid postage, and shall provide a space in which the vehicle owner may indicate the name and address of the person to whom the vehicle, engine, or trailer was sold or transferred. This update will also give manufacturers the option to collect new owner information electronically using a website link, QR code, etc., in lieu of using a physical card. Next slide, please. Yeah, thank you for your time. If you have any questions or comments, please feel free to contact me via email using this email address listed here on the slide. Thank you.
Thank you, Adil. Okay, now we'll take questions on Adil's presentation. Again, you can use the Q&A feature or raise hand features to ask your questions at this time. I'm not seeing any questions right now, but maybe it takes a second for people to come up with their questions. We have a few questions from the previous section that maybe we can answer. One is from Neelish Prasad. I have a 2018 Freightliner Cascadia. Can it be used in California? And I believe Kim wanted to answer this question.
Yeah, thank you, Christian. So today's workshop is about changes to our omnibus regulation, which is the emission standards and test procedures that engine manufacturers need to meet to legally sell engines in California. And I think what Mr. Prasad is asking about is likely a different regulation. So let me give my answer, and then if he's got more specific questions, we can refer him to the Advanced Clean Fleet team. So I think Mr. Prasad's asking about under CARB's Advanced Clean Fleet regulation, whether he can still operate a 2018 Freightliner Cascadia. And it depends what kind of fleet he's in. If he's in a drayage fleet and he reported that truck into the drayage registry last year, then he'd still be able to operate it for its remaining useful life. If he's part of a high priority fleet, which is a fleet of 50 or over 50 million in revenue, he could keep operating that truck for the rest of its useful life, but he would need, as he adds trucks to his fleet, they would need to be zero emission. So if you have more detail questions regarding the Advanced Clean Fleet regulation, you could Google that and find your way to the experts on that regulation. Thank you.
Thanks, Kim. Our next, we do have a EWR related question from Tim French. Can CARB confirm that it will be revising the EWIR program as specified in Appendix C to the Clean Trucks Partnership Agreement, and that for model 2024 through 2034, CARB will look at all relevant information submitted by manufacturers before making determinations whether a EWR related recall is required?
Hi, Tim. Thank you for that question. The existing regulation already requires us to look at all relevant information pursuant to California Code of Regulations, Section 2148, the evaluation for need of recall. So we'll definitely be reviewing all of that information, including information that's submitted through warranty reports.
Thank you, Adil. I'm not seeing any hands raised or new questions on EWIR. But we do have another question from Tim French on ABT. We'll try and answer. With respect to ABT alignment, will CARB recognize and allow for the use of credits earned under EPA's interim model year 2026 early low NOx provisions? C 1036.150 and 1036.705.
I can take that one. I think the answer to that one is yes. Also, we'll be adopting those provisions as well.
Thank you, Paul. We have one question for OBD, but I think we'll wait until the OBD slides come to try and tackle that question.
Yeah.
Let's give it like maybe 15 seconds if anyone has a raised hand or a question on EWR. Otherwise, we'll move on to our first OBD presentation. Let me share screen again. Okay, I'm not seeing any questions. Thank you, Adil.
Thank you.
And our next presentation is the proposed amendments to real NOx tracking requirements for heavy-duty diesel engines by Paul Hendrick. Take it away, Paul.
All right, thank you, Christian. Yes, my name is Paul Hendrick, and I'm part of the onboard diagnostics branch at CARB, and I'm going to talk about proposed amendments to real NOx tracking. I'm going to spend some time at first going over some background about what is real, what does it look like, how does it work, and then get into how we are proposing to change it. So next slide, please. So REAL stands for Real Emissions Assessment Logging. It's kind of an umbrella term to cover requirements for on-road vehicles to track and report data that characterizes their own NOx emissions and greenhouse gas emissions. And you can see in the table there, it touches light duty, medium duty, and heavy duty on-road vehicles. GHG tracking in particular is quite broad, covering all of those categories, as well as the different engine types, diesels, gasoline, and natural gas. NOx tracking is limited to diesel engines, and in particular medium duty and heavy duty diesels, where most of the diesels are. And that started in 2022 model year. So it's relatively new, but we do have a few model years under our belt. Yeah, and actually, so the reason it's specifically targeting diesel engines is because they come with NOx sensors, and that really makes the tracking of NOx emissions possible. And you'll see at the bottom of the slide also we have a draft proposal that we're working on currently that would extend real NOx tracking to Tier 5 off-road diesels as well. The next slide, please. This slide is just to give you something for your reference so you can see where the real regulations exist in California regulations. So both the on the heavy duty and light and medium duty regulations. So just for your reference, we can go on to the next slide. And really what we're going to be focusing on from this point going forward is real NOx tracking. And so this real NOx tracking is actually quite important. The data we get from it provides feedback on our regulatory programs as to like how we're doing out there in the real world. And also the data improves our emissions inventory and serves as a quick screening tool to help flag any potential emissions issues that might be out there. One of the kind of nice aspects of REAL is that it really just leverages existing technology and hardware to estimate and track NOx emissions. So there's nothing terribly revolutionary here. The NOx sensor pictured there is kind of one of the key components that makes this possible. And I'll just point out at the bottom there that we do have a a minimum NOx mass accuracy requirement. So we want the engine control module to be able to estimate NOx mass emissions within plus or minus 20% or plus or minus 0.1 grams per brake horsepower hour of the numbers that you get when you test the engine in the lab during certification testing. And I'll add that looking at a few years of cert data, this requirement has been easily satisfied by manufacturers. So next slide, please. Okay, so this table shows some of the structure of real NOx tracking. In particular, what are the parameters that get tracked and the different time frames involved. So we've got 6 different parameters: NOx mass, engine out, NOx mass at the tailpipe, engine output energy, or essentially the net work output of the engine, distance traveled, engine runtime, and vehicle fuel consumption. So those are the 6 parameters, and they get stored in these different arrays. The 3 arrays in orange, active 100-hour, stored 100-hour, and lifetime array, those 3 are tracking data when the NOx sensors are awake and providing concentration data. Then the last array, the lifetime engine activity array, is actually recording data continuously. So whether or not the NOx sensors are active or not yet active, such as when after key on and exhaust is cold. Let's see. Yes, so we've got a couple of different time frames shown here. The 100-hour arrays are capturing data that's more current, like within the last 100 hours. And then the lifetime is just a continuously increasing quantity that represents, as the name suggests the lifetime values. Now, if you look in each of these cells that has an X, okay, you focus in on one particular X. Each X is actually a set of bins. It's a set of bins. And these different bins are shown on the next slide. Okay, this is how the data gets sort of divided up. We have a table of bins that is defined by different intervals of vehicle speed at the top and windows of rated power, percent of rated power. So for instance, if at a given moment, the truck is operating at 15% of its rated power and driving at 5 kilometers per hour, that data point would get stored in bin 3. And so these bins get they're also summed. The total of bin 2 through 14 is stored in bin 1. There's a few special bins off to the right. The not to exceed bin, that's the NTE bin, the regen bin, and which is the DPF regeneration bin, and the mill on bin. So those store data under special circumstances. So when the not to exceed NTE conditions are satisfied, that's when bin 15 will be storing data. And when the DPF is when an active regen event is being commanded for the DPF, that's when the regen bin will be storing data. And then when a malfunction has been detected by the OBD system and the mill is being illuminated, that's when data will be stored in bin 17. And not, in that case, not in the other bins. So if there's a malfunction, the data goes into the red bin. Next slide, please. Okay, So that's basically what REAL looks like. And as you saw, we do have an NTE bin in the current structure to reflect sort of the previous in-use compliance evaluation method. But as mentioned previously, that has changed, and we want to keep up with those changes. So the low NOx omnibus rulemaking moved from the NTE to the 3-bin moving average window methodology that allows for analysis of idle and low load and higher load operation. But again, as part of the Clean Truck Partnership, we're agreeing to align with US EPA's methodology, which is only slightly different in this case. Instead of looking at 3 bins, it's 2 bins, both the idle and essentially non-idle operation. So that's what we're proposing today, is to add these 2-bin MA bins to our REAL structure so that we're aligned. The next slide, please. Okay, so this slide is showing basically what I just described. So we're no longer going to be using the NTE bin for future engines, and we're gonna add these 2 bin MA bins, bin A and B here. Bin A, the idle bin. When your 300-second chunk of data averages to less than or equal to 6% of rated power, it would be put in bin A. But if the average rated power is greater than 6%, it would be stored into bin B. I'll add that we want to work with the relevant SAE committees to standardize these changes. And next slide, please. One thing that we're sensitive to is the need to economize on the engine control module's resources in terms of memory and processing. And so we're proposing a targeted use of these 2 bins, A and B. So rather than having them across the board for all parameters and all arrays, what we are proposing is shown here. So bins A and B would be added to the NOx mass tailpipe parameter, but not the engine out parameter. So the priority here is getting that tailpipe NOx mass data. So so bins A and B are there for the 100-hour arrays and the lifetime array. And for engine output energy, we would add bin B. That's where we need to get we need to get the work term to be able to calculate the gram per unit work values for bin B. But bin A does not need work in that for that evaluation, and so we will only need to add bin A for the engine runtime. It's a grams per hour based standard. And then also we're adding bin B for engine runtime to give us a sense for how much time is being spent in one mode of operation versus another, A versus B. Next slide, please. So the goal here, when incorporating 2-bin MA into REAL, is we want to use a methodology that's as close as possible to the methodology that's used when post-processing PEMS data in the actual in-use compliance evaluation method. So it's gonna again be using these 300-second windows of parameter data that get stored every second. And we want to define criteria to determine what is valid or not valid for a given second of data that is as close as possible to the official method used when post-processing PENS data. So this slide kind of goes over kind of our first stab at trying to define those different conditions. So data would be deemed invalid and therefore not included in a 300-second window if real tracking is paused for some reason, such as there's a malfunction detected with the tailpipe NOx sensor, or if the mill is on for, generally speaking, for other types of malfunctions as well. And also if the NOx sensor controller is indicating that the reading is not stable, that could be another reason to not include data in this window. Or if an infrequent regeneration is active, such as a DPF regeneration event, but not limited to a DPF regeneration event. And then also, there is an altitude criterion here. Basically, anything above, if the truck is above 5,500 feet, that operation would be deemed invalid. And what we're proposing is sort of a surrogate for that, just using a barometric pressure equivalent, more or less, of any pressure less than 82.5 kilopascals. Because trucks will have that signal available to them, but not necessarily an altimeter. And then there's a couple of ambient temperature related exclusions, and yeah, the first two that are model year dependent here are part of the Clean Truck Partnership details, basically, so that for 27 to 30 model year, the ambient temperature exclusion would be anything less than 5 degrees Celsius. But then for 2031 and beyond, it would be less than 0 degrees Celsius. That's on the cold side. And then on the hot side, there's another exclusion that is tied to elevation again. And so similarly, instead of using an actual elevation value, we're proposing a barometric pressure equivalent. And then there's the question of how to manage a window of data when you encounter some criteria that, or some conditions that make data invalid. So we want to align with where EPA is on this one. And so our interpretation of that is that a window can extend to 599 seconds maximum, where essentially you have 300 seconds of valid data within that interval, plus a maximum of 299 invalid seconds. So in other words, you don't want to spread out your 300-second window too far. Then it starts to lose meaning about, what is a window of operation. And then the last bullet point there, this is actually a simplification relative to the official method, where you would essentially stitch together portions of windows across a key cycle to combine and make one complete window. So if you have a partial window at the end of a key cycle, the truck driver is done driving, keys off, you have some partial data there. It's not, you don't have a full window at the end. And you'd have to, store it in memory somehow, and then wait till the next drive cycle, look for another opportunity to grab more data to complete your window. That's we don't want to do that. That's too complicated, and we don't need it. We're going to get a lot of data anyway in these larger time frames that Real deals with. It's not just one one workday basically. So we don't want to have to add the burden on the processor memory and so on to deal with partial window data. And so anything at the end of the key cycle that's left over will just not be used. Okay. Next slide, please. These are a couple of sort of discussion topics to consider. So the first one relates to the fuel consumption parameter. So we're considering whether tube-in-MA tracking should include fuel consumption. And it may have some potential for facilitating a comparison of real NOx tracking data with data that you would get from a PEMS-based method. So, if anybody out there feels strongly about this, we'd like to hear about it. And then the second bullet point relates to the tube-in-MA window methodology. Basically, what I was going over in that the previous slide. In the sense that we want to align the methodology employed by the engine control module that's tracking tube-in-MA data as closely as possible with the method that's used when post-processing PEMS collected data. So we showed you kind of what our stab at it was, trying to get close, and we'd like to hear your feedback on if there's some area where it can be improved or something. We'd like to have that discussion. So that is it for me, Christian.
Thank you, Paul. Okay, we already have questions rolling in. Our first question is from Daniel Kowalski. Will CARB OBD approval will be required for hybrid systems and dual EO once again be needed if EPA engine is used? And I believe Michael Regenfuss would like to answer this.
Yeah, I'll take that, Christian. So I think this is a question that's maybe unrelated to Paul's presentation, but we can comment on it anyways. I think the question really, it sounds like it's really about a federal only certification. And if that's the case, they would need to talk to EPA. That said, that the EPA OBD regulation references the CARB OBD requirements and acknowledges CARB approvals. So I would expect that monitoring of the hybrid systems and overall OBD compliance of the engine and hybrid system would still be required. And if there is a relevant CARB OBD approval for the engine and or hybrid system, I would expect EPA to take that into consideration. But I think in the end that the engine and hybrid manufacturers, I don't know if those are one and the same or different entities, but they need to talk to EPA about what's expected and required and sort of how the certificates would be issued at the federal level.
Thank you, Mike. We have a question. Will there be a break in between any of the PowerPoints? We don't have any breaks scheduled in today's agenda. If you feel like you might be missing out, I'd like to remind you that the recording of today's webinar will be on CARB's YouTube website. And so anything you think you might have missed out, you can catch up on that.
And also, Christian, if I may, I would ask the individual to please identify themselves and their affiliation rather than going with an anonymous attendee, please.
Thank you.
Thanks.
Our next question comes from Dan Depler. Will NOx real tracking be publicly available? I'm sorry, I'll say it again. Maybe I said it unclear. This question is from Dan Depler. Will the NOx real tracking data be publicly available?
I don't know if Mike Reagan first wants to comment on that. I don't have an answer. That's a legal question. So
Well, they're available to download through the OBD connector on the engine or the truck. So they're, you know, for people that have access to the truck, they have access to that data.
Thanks, Mike. Our next question is, I have trouble explaining to others how exactly these tracking requirements improve air quality or aid in service. Can you provide an explanation what benefit normal consumers gain from these trackers?
Yeah, I could take that one. The trackers are more intended for CARB data and CARB usage. They provide sort of valuable information kind of at the fleet level, how trucks are performing in the field, and they could be used as a sort of a feedback loop to see if our regulatory programs are accomplishing the benefits that we're intending and expecting them to accomplish. And then the data can also be used to screen trucks for high emissions, to see if there's you know, subpopulations that we want to focus on to do compliance work.
Thank you, Mike. Our next question comes from Rob Weiss. Are the two-bin moving average window changes also for 2027 plus model year and later? Will this be aligned with the J1979-2 UDS implementation?
Yeah, I think these changes will certainly be incorporated into UDS, but not necessarily in time for that 27 model year implementation. You know, we need to work on sort of the technical details to get them into the regulations. We need to work with SAE International to define the standardization requirements that the manufacturers can build to, and then we have to take sort of the lead time into consideration for all that to happen, consistent with what we've agreed in the Clean Truck Partnership.
Thanks, Mike. Our next question comes from Ioma Emirium. In what model year are the proposed real changes replacing NTE with two-bin moving average bins be expected to be implemented?
Yeah, I think that one's kind of like the last answer to the last question. We kind of have just the work to go through to get all this in place, and then once we've got that established, we'll have the appropriate lead time.
Thank you. Our next comment is from Steve Berry. The interpretation of EPA's data concatenation requirements appears to be incorrect. It's good that you're looking to align, and he'd be glad to set up a time to discuss that.
Yeah, we'd certainly be happy to talk about it.
Our next question comes from anonymous attendee. Real NOx is not real. All high exciting peaks are missed during the cold phase as the NOx sensor is not ready during the morning coffee time. And he has two questions. One, any requirement for the ratio valid NOx data in hours compared to the total engine runtime in hours? And the second question is, should any reg or recommendations be made getting the NOx sensor ready, then let the engines run?
Yeah, I think on the first one, we don't have a specification for that ratio, but clearly the data will allow us to look at it. I think there, as we within the OBD requirements, we sort of expect the NOx sensors to be active as much as possible, but there are inherent technology limitations on how quickly they can be active after a cold start. We're not kind of anticipating any recommendations at this point to do something to get the NOx sensors ready, like letting the engines run. I think that particularly might be counterproductive because it's would just otherwise be generating emissions for the sake of collecting this data, or and you still have to go through the process of letting the sensors come online. So we're not anticipating anything along these lines at this point.
Thank you, Mike. Our next question comes from Marcus Thorin. NOx tracking plus or minus 20% is on a 200 milligram brake horsepower hour compared to HCFTP. How will this accuracy change with the new 35 milligram standard?
And maybe, Paul, can you jump in on this one?
Yeah, sure. We don't have a proposal right now to tighten up on that accuracy requirement, but we are looking at data to see what might make sense going forward in the future. So it's a good question.
Thank you. Our next question comes from Dan Depler. Will this data be tracked via OTA or will it be collected on the truck?
It's not required to be tracked over the air per the OBD regulation. I suppose the manufacturers are in a position to do that, and they very well may. But we don't mandate that.
Thank you. Our next question comes from Eric Feely. For NOx mass sensor accuracy requirement, can you say more about the plus or minus 20% versus the plus or minus 0.1 gram per brake horsepower hour? With the lower NOx standard, it seems like 0.1 gram is a high accuracy tolerance. I believe Paul wanted to answer.
Yeah, that's correct. It is pretty high, and really, those original accuracy requirements were really a reflection of older model year engine data, and were meant to simply reflect basically, without making any special effort to meet a standard, what would trucks be able to comply with, sort of to prevent, to keep the performance and accuracy at least what it appeared to be capable of, a few years ago. So yeah, like I said before, we're going to continue to look at data as we get more to see if we can, reevaluate that for future engines.
Thank you. Okay. Now doing a time check. Now's a good time to move on to our next OBD presentation by Young Yu. We currently don't have any more OBD questions in our queue, so this is a good time to switch over. If you do have any questions, we still have our OBD session available after Young's presentation and at the end of all presentations today. Okay, Young, please take it away with the diesel onboard diagnostic demonstration engine aging.
Thank you, Chris. Yeah, good morning, everyone. My name is Yongyu. I'm from the same branch as Paul Hendrick, from CARB, OBD branch. And today I will give a talk regarding the diesel OBD demonstration engine aging topic. The first, I will introduce the background for the diesel OBD demonstration testing. OBD regulations requires OBD system demonstration testing for OBD certification in annual base. Regulation requires 1 to 3 engine demonstration, depends on the engine family manufacturer certified, per manufacturer per model year. To conduct this OBD demonstration, the mid-function parts will be implemented one at a time on engine and after treatment system, then conduct the emission testing to show OBD system implement the mid-functions before the emission exceeds the OBD mid-function criteria. The regulation requires the testing conduct on engine and after treatment system that is allowed to be rapidly aged to represent the full useful life FUL aging. Through this aging, we ensure the OBD system calibration accounts for real-world aging, and the real-world mid-functions are detected before emission exceeds applicable mid-function criteria in the regulation. Next slide. Here are the requirements for the complete engine after-treatment system aging. First, the OBD regulation sets the minimum auxiliary aging hours for the complete system, including engine emission controls, and after-treatment. For heavy-duty engines, the minimum hours will be 2,500 hours. For mid-heavy-duty engines, 1,063 hours. For light heavy-duty engines, 632 hours. For the aging process, it must be considered the following parameters: operation at rated horsepower, operation at the load level greater than 80% of the rated torque, with sustained interval at 100% of the rated torque. Operation of transit conditions, for example, Model 2 of the Federal Test Procedure Cycle. Calculate the number of the regeneration events experienced over the FUL. Thermal cycle events, which means system shut down with the subsequent cold start. Next slide. In addition, the regulation also required the validation of the OBD demonstration engine aging process against actual FUL in use engine to ensure this aging process is representative. Validation must include the following metrics of the FUL: fuel burn rate, total fuel consumed, and the reduct used by the system. The validation also including the correlation between a representative actual FUL system and the test engines of all adaptation learning parameters used to maintain emission control performance to the applicable emission certification standard of the life of the system. Next slide, please. US EPA and the CARB for the emission certification has the engine aging protocol, but different primary purpose to OBD demonstration testing. The aging and the deterioration factor used to be sure the engine will meet the emission standard throughout the useful life. The difference between the US EPA aging versus CARB's OBD demonstration aging, including the few hours of the aging on a complete system, means engine plus after treatment for heavy-duty engines. And the US EPA, the DF aging allows accelerated bench aging for the after treatment device, including accelerated chemical exposure, including low oil and sulfur. Next slide. At the end of this presentation, I want to explore the opportunities to preserve the representative OBD demonstration and harmonize between the OBD agent and the DF agent. We're seeking the feedback on the following. The first, how the engine and emission control adaptation parameters values compared to the US EPA aging protocol versus CARB's OBD protocol. For instance, amount of available authority used up, adaptation. Second, the impact on the aging protocol difference on OBD system performance. The third, the parts of this protocol that can be harmonized without compromise OBD performance. Thank you. I end my presentation. Any questions and comments?
Oh, thank you, Young. Okay, any questions on the OBD demonstration in aging? Please use the Q&A feature or raise hand feature if you have any questions. Currently, I'm not seeing any questions. Okay, we have a question from Nathan Murphy. Will CARB provide guidance for a new OEM or new systems where no historical data exists? One cannot compare existing full useful life data for a new technology.
Yeah, I think in that case, we'd expect manufacturers to come talk to us and share with us whatever data they do have and come up with a plan to ultimately sort of generate the data that shows the correlation.
Thank you. Our next comment comes from Brad Edelman. iCarb DF cycle 1 acceptable?
Yeah, I'm not sure what that means. Maybe you can provide kind of further details, and we'd be happy to talk about it.
Yeah. Thanks, Brad. You can add more clarification. Our next question comes from Eric Feely. Can you say more about how DFs are updated by EPA? My understanding of DF is that they can sometimes be outdated.
Yeah, maybe someone else.
Yeah, I'll take one, Mike. Yeah. So the proposal by EPA has basically allows the manufacturer to there are two stages for aging a system. One is to put the engine and after treatment system on the dynamometer and then age it. I forget what the hours are, but I think it's up to 1,500 hours or something of that order. And then afterwards, they remove the after treatment and they put that through an accelerated aging process. And the accelerated aging process is, they have a prescribed methodology to do that, but at the same time, they allow the OEMs the flexibility to come up with, if they can verify any kind of accelerated after treatment aging. In terms of DFs being outdated, there is a process to carry across DFs from one engine family to another. And I think that process will continue. There is an evaluation of that carrying across of the DFs. The CARB and EPA will look at data, make sure the architectures are the same, make sure they're similar. The platforms are similar where the carrying across of the DFs will happen.
Thank you, Paul.
Sure.
A follow-up from Brad Edelman. For OBD aging, is cycle 1, which has approximately 105 hours of FTP and RMC with an additional LLC, idle and shutdown, meet the requirements stated earlier?
So let me, before Mike answers that question, let me say that's not for OBD aging, that's for certification process where, we have a prescribed cycle that was described here. That was part of our original omnibus proposal, and I think EPA sort of adopted that. But I'm not, I don't know whether Mike wants to comment on, whether that's a cycle for OBD aging or not.
Yeah, well, yeah, Paul, I would like to say that this is sort of the purpose of teeing up this topic to discuss whether stuff like that is appropriate and how it appropriately ages the engine for the sake of OBD demonstrations.
Okay, thank you, Paul and Mike. This time I'm not seeing any new questions. Oh, we have one here from Dan Potter. Now that manufacturers and research institutions have experience with the DAC and other DF validation methods that were not available at the time of the Omnibus and Clean Trucks plan were created, we would recommend that CARB engage with EMA, EPA, and individual manufacturers to discuss the results and the appropriate methods for DF extrapolations considering OBD certification, etc.
Yeah, we're open to having that conversation, and we'd like to have that conversation along the lines of what we've teed up today to understand how that experience that's been gained based on the protocols that have been defined, how those work, how they apply for OBD, and are they going to develop aged test engines that really yield representative OBD performance. So we'd be happy to engage and have the discussion.
Thank you. I'm not seeing any questions in the queue, but we still have time for Q&A on OBD. I'll start transitioning the slides to our final presentation, but if there are any more questions on OBD, feel free to ask now and we can still get to them. Okay, I'm still not seeing any questions on OBD, so maybe now's a good time to transition to our last presentation, and that's going to be the Omnibus Amendments Manufacturer in-Use Testing Program by Thomas Montes.
Okay, can you hear me okay?
We can hear you, Tom.
Okay. Good morning or good afternoon, depending on where you are. My name is Thomas Montes. I'm the branch chief over in-use programs with CARB. And today I'll be talking about the Omnibus amendments relative to heavy-duty in-use testing. Next slide, please. Among the in-use test program discrepancies between US EPA's CTP and CARB's Omnibus regulations, CARB staff are proposing to align with EPA's rule with a few exceptions outlined below. First, regarding the use of commercially available biodiesel fuel for in-use testing. CARB is proposing to hang on to that as it is found in the Omnibus regulation. Second, the compliance determination based on the number of pass-fail tests, in addition to the sum over sum emissions, when 3 or more vehicles fail for the same pollutant in the same bin, as found in the Omnibus regulation. And lastly, we are proposing the use of the PEMS system or the chassis dynamometer for in-use compliance testing to verify idle emissions for the Omnibus regulation. Next slide. Here we just have a cleaned up table with the same 3 proposed amendments that I just outlined, with the citations on the right for easy reference. Okay, next slide, Christian. So let's start off with the biofuel proposed amendment. EPA understands that manufacturers have little control over the quality of fuel over the years of in-use operation, and CARB staff believe the in-use testing program is intended to reflect real-world emissions with real-world fuel. Our current analysis of commercially available biodiesel fuel does not indicate any concerns with fuel contaminants that would harm or otherwise degrade the engine's emission control system, which we understand EPA agrees in part. And we also want to ensure manufacturers do not prohibit the use of CARB-approved commercial fuel in a statement in the manufacturer's maintenance instructions in the owner's manual, nor deny warranty based on the use of such fuels. Next slide, please. And here we have just outlined the comparison with the EPA rule on the left, stating the use of biofuel relative to testing. You see that in the bottom half on the left slide, it states that fuel that is not allowed or otherwise indicated as unacceptable fuel in the operator's manual. But on the right, we have CARB's proposed language, which mentions that CARB may use any commercially available biodiesel fuel blend for in-use testing. And on the bottom right, it states once again, relative to in-use testing, you may drain the fuel tank and refill prior to testing with diesel fuel conforming to ASTM D975 or commercially available biodiesel fuel. Okay, next slide, please. And the second proposal deals with the pass-fail criteria for in-use testing. And to begin with, when 2 or more engines do not comply with off-cycle bin standards, the US EPA CTP requires 10 engines to be tested. And when 10 engines are tested, the compliance determination for EPA CTP is based on the arithmetic mean of the bin emissions from these 10 engine tests for each pollutant. Now, CARB's proposal will add the following criteria for pass-fail determination of an engine family. And that is specifically if 3 or more engines do not comply with the off-cycle bin standards for the same pollutant in the same bin, the tested engine family would be determined non-compliant. So we feel this would protect against outlier data points that may pull the engine family average down. And in addition, we feel if we see 3 out of 10 in-use engines with high emissions, we feel that's an indication of more of a chronic in-use emissions control defect that needs to be addressed. That is, could be 30% or more of the in-use population. And that's something CARB would like to take a look at further, hence the basis for our proposal. to update the pass-fail criteria. Okay, next slide, please. And here, once again, we have, just for ease of reference, the EPA's CTP rule on the left, which discusses the calculation of the arithmetic mean of the bin emissions to determine pass or fail. And then on the right, you'll see CARB's proposed language in Part 86. And on the right in the middle, it states the sum over sum emissions of the same pollutant and the same bin, they exceed the in-use threshold for 3 or more tests. This would be deemed as non-compliant. Alrighty, next slide, please. And here's the last proposal I have to share. This regarding the use of PEMS or a chassis dynamometer to verify idle emissions. Now, the US CTP requirements allow heavy-duty diesel engines to be optionally certified to the clean idle NOx emission standard of 30 grams per hour for model years 24 through 26 and 10 grams per hour for model years 27 and later. The US EPA CTP procedures are based on engine dynamometer testing. However, CARB's proposal would add to the provision to allow the use of PEMS or chassis dynamometer for in-use compliance testing and verification of idle emissions. Next slide, please. And in a similar format, we have EPA's existing CTP language on the left, and on the right, we have CARB's proposed language in Part 86, which states at the bottom, in-use compliance emission testing may be conducted using chassis dynamometer in the laboratory or using an onboard PEMS system. Okay, I think that brings me to the end of my slides. Thank you.
Thank you, Tom. Okay, now's the time for questions on the in-use proposal. We already have some questions in the queue. Our first is from Jackie Yeager. What is the max biodiesel blend that is commercially available in California? For example, B7, B20, etc.
Yeah, that's my understanding. It's B20, but I'm not sure if we have a better fuels person on the line. Christian, would Paul, do you have a more direct answer for that?
No, I don't. We'll have to research them.
Okay.
But I think that the main issue here is that, you know, whatever is available at the pump, that should be acceptable. And then the OEMs cannot sort of have a language in their owner's manual that says that if your bio blend is above 20% or something, your warranty is voided. And, that's the sort of a scenario that we would like to ideally avoid.
Right. Okay.
Thank you, Jackie. Our next question comes from Tim French. CARB's maintenance and distinct pass-fail requirements will make CARB's in-use standards more stringent than EPA's, which seems inconsistent with the partnership agreement. Has CARB definitively decided that it will maintain this critical discrepancy?
Hi, Tim. Yeah, I can take that. The answer is no. We're definitely not definitive, if that makes sense. We're not etched it in stone just yet. We'd like to hear the concerns, manufacturer feedback. However, we are aware that the agreement allows CARB to evaluate alignment where it is warranted. That is, evaluate alignment relative to the agreement with in the CTP. And the agreement does state that we can align certain aspects with the CTP or holistically. So all we want to do is, with this presentation is open this item up for discussion and see if there's a better way to meet our common goals here.
Thank you. Our next question comes from Sarah Funk. Is renewable diesel included as biodiesel for in-use testing?
Yeah, I don't know the answer to that question. We'll have to look that one up. We'll get back to you on that one, Sarah.
I can chime in at least for R99 that which is renewable diesel, that renewable diesel meets all the same specs as regular diesel. So it should behave just like regular diesel.
Thank you, Kim. The next question comes from Sean Snyder. Will CARB align with EPA with regards to NOx drift allowance for plus or minus 2.5 ppm per cyclic zero check with a plus or minus 10 ppm of the test day, as well as over the range allowance of 1% of all the test day? If we have Abraham on the line.
Yeah, that's what I was thinking of. This is relative to PEMS testing.
Yeah.
Yeah, Abraham, do you have an answer for that one?
Yes, I can answer the question.
Thank you.
Yes, basically, yeah, we'll align that one. That's part of the big alignment with the EPA rule, except those three items.
Okay, great.
Thank you, Abraham. Yeah, I'm not seeing any questions in our queue on the in-use proposal here, but we still have time for questions. Time allotted questions specific to in-use. Okay, we have a question from Dan Potter. Has ARB considered using language to limit manufacturer liability for commercially available fuel to fuel that was commercially available at a time the vehicle was certified? It seems like it could be difficult for a manufacturer to ensure compliance with in-use standards and appropriately warrant parts for fuels that might be commercially available in California in the future.
Yeah, I can take that one. Yeah, Dan, I think the similar line of reasoning would still hold true, regardless of whether we are using diesel fuel, straight diesel, or a blend of bio diesel. And specifically, what I mean there is, if a vehicle or a test group of vehicles show that the emission control system was damaged due to contamination, not due to a manufacturer defect, then I don't see that CARB would reach the conclusion that the manufacturer is liable for the owner's own contamination of the emission control system. So I guess that liability limitation, I kind of see in that play out in a similar way, whether we're dealing with straight diesel or with the biofuel blend. However, if you're thinking of something different there, yeah, please provide some specifics. If you have any more specific, maybe proposed language you'd like to make that point more clear as we go forward. Thank you, Dan.
Thank you. I'm not seeing any questions specific to in-use. Oh, sorry, maybe Dan has a follow-up here. Thank you for your comments, Tom. I'm considering a scenario where, for example, B20 is commercially available today, but perhaps someday in the future, CARB would approve B100 as commercially available in California. I appreciate the opportunity to talk further on this and consider language revisions. Thank you.
Okay, thank you for the input there, Dan.
Well, thank you, Tom. I'd like at this time to open up the questions for any of the presentations that we had today, whether it's the alignment topics, EWI or OBD, or in use again. Feel free to use the Q&A feature within Zoom or the raise hand options if you'd like to ask a question verbally. I currently don't see any questions, but we'll still stand by for any questions on any of the topics today. Okay, we have a question from Steve Berry. Steve Berry asked, not sure if someone asked, but is CARB adopting the interim in-use testing pass-fail provisions for 2027 and 2028?
Paul, can you help with that?
Yeah, I can take that one, Tom. You may not be familiar with those. So I think the pass-fail criteria, Tom's presentation indicates that, we may have we're thinking sort of a different pass-fail criteria. So those interim provisions would also be part of the conversations that we would like to have with the stakeholders.
Thank you. Don't have any questions in the queue or hands raised. Participants are welcome to ask away. Yeah, I don't see any additional questions in the queue or hands raised. Maybe we should move on to our next step slide. Start sharing.
Thank you, Christian. So we've covered a lot of different topics today, and I know there are still some questions and clarifications that are still pending. So we're thinking that there might be a need to have a second workshop later on this year, and the sort of the timelines that we're thinking is around December. Of course, we would like to hear any kind of comments and feedback from all stakeholders as soon as possible while we start working on our rulemaking documents. Our plan is to sort of finalize the reg language and everything by August of next year, and per our agreement in the Clean Truck Partnership, We intend to proceed with publishing the 45-day notice in September of next year with an anticipated board date of November 25. Again, we introduced some new concepts and ideas. We want to hear from you. We want to hear from all stakeholders what they think. We're looking forward to receiving feedback from you guys. And then let's go to the next slide, Christian. So here are some contact details for the various proposals that we introduced. For omnibus amendments, we have our regular email address, and we look forward to hearing your comments. We also have the contacts for the corrective action requirements, OBD amendments, and in-use amendments. So any feedback or any thoughts, we'd really appreciate to hear from you. That pretty much summarizes my concluding remarks.
Well, I don't see any additional questions here on my end either. So
Okay.
again, we thank you everyone for coming to our workshop today. And I'm sorry, Kim, did you want to mention
No,
something?
just thank you. Yep.
Thank you everyone for coming. If you want to see a recording on CARB's YouTube website, maybe within a week it will be posted. Thank you everyone. Bye-bye.
Bye-bye. I appreciate it.
Thank you.